Guys, to hear homework 246. So let's start. First of all, facts. When Earth's axis is tilted away from the sun, it is winter. Okay. By that I mean the north pole of Earth's axis. Okay. So this part right here, the north part, the north part, the north part. When Earth's axis is tilted towards the sun, it is summer, or maybe the first day of summer. Winter. Away toward. That is key. You need to know that and apply it here. So. Before we look at this picture, let's look at another diagram here that shows the same thing. Where's the North Pole tilted towards the sun? It's tilted towards the sun here. For us, it's summer. It's tilted away from the sun like this, tilted away here. So this would be the first day of winter. And then these here are a little hard to see, are tilted kind of towards the side. So that's one sort of diagram. On this one, look, it's kind of from the other perspective. This axis is tilted this way, this way, this way, and this way. Therefore, represent summer, first day of summer. We're looking for summer, the Earth's axis tilted towards the sun. It is this right here. This is tilted towards the sun. You want to draw it in. So this is summer. June 21st is the first day of summer. That's the first one. 2, on the diagram above, label position that represents winter, December 21st, and winter tilted away from the sun. This right here, we say the North Pole tilted away. This is winter 12/21, December 21st. On the diagram above, draw on the approximate location of Earth on November 20th. Label it. So, I guess the idea is, this is June 21st. It goes this way. This is winter. So this from here to here is 6 months. This here is halfway is 3 months. So if this is June 21st, this is September 21st, and in October, November. So we're going to estimate about a month before that. Maybe it's around here. Okay? November, what did I say, 20th. About there, somewhere in there. Not here, that's going to be January and February out here. On the diagram above, draw on number 4. Draw on the approximate location of Earth on your birthday. Label it with a date. Let's say, your birthday, people's birthdays will be different. Let's say your birthday is, January 28th. January 28th. Where would that be? Well, this is December 21st, right? So we're going to January, February, March. This is March 31st. So January 28th may be about here. And that's going to vary depending on when your birthday is. But okay. That is the first page. Here we go, second page. This shows the, one thing I do want to label with this is, this is the horizon right here. I do want to label that this is the same day as March 21st, and maybe that's really going to help. March 21st and September 23rd have the same path, rise due east, set due west. That's key. When's your birthday? Let's pick a day. Let's call it, let's do August 17th. I'm just calling out a random day. When's your birthday? On the diagram above, do your best to draw in the path of the sun on your birthday. So this is sort of June. This is the path goes this way, and then from June it starts going back down. September, December, and then from December, January, February, March. It kind of goes in between here. So if this is September 23rd, what am I doing? August 17th is about 2 months after June 23rd, a month away from here. So maybe it's about here. Okay, and label it August 17th. It's an approximation. Okay. Fact: solar noon, time when the sun is highest in the sky for that day. It's usually around 12 noon. If you're in daylight savings, you set the clocks ahead in the spring. It's around 1 o'clock. Okay, but if we didn't have that, solar noon, highest in the day. And in New York, and I mean anywhere north of the equator, really, is what I really mean. Anywhere in the U.S., shadows point due north at solar noon. That's key, at solar noon. Okay, so you always know the direction. Check this out. This requires some thinking. Not that easy, but something that you do need to have a grasp on. On the diagram of the post and shadow, which is this, draw an arrow that indicates south, label it south. This is key. This diagram was drawn at solar noon on July 4th. So we got to know, at solar noon, this arrow, this shadow is due north. So then I know this way is north. Okay. Therefore, opposite that, this way will be south. That's what this question 7 asks, south. Okay. And then mentally, okay, so We'll just go on to 8. On the diagram of the post, draw the shadow of the post that would be cast at 8 a.m. Location and length matter. Location is going to be a bit estimated, but length is going to be estimated, but there is some sort of reason to this. So, excuse me. You got to realize north and south, and so west is this way, and then like due east is this way, east. Okay, so the sun always rises somewhere in the east. It's going to rise over here somewhere. The sun. And the idea is July 4th at 8 o'clock, the sun's been up for a while, but the sun is somewhere over here. The sun may be somewhere. It's hard to draw the three-dimensional up in the sky. Here's the sun casting light this way. So the shadow is going to go in this direction. And then the question is, the sun is lower in the sky at 8 a.m. than it is at noon because it rises up until noon. So the shadow should be, question you want to ask yourself, will the shadow be longer or shorter than this? Think about it. Okay, I'm going to tell you, the sun will be lower in the sky. Therefore, the shadow will be longer than this. So your shadow must be longer than this, and it should be somewhere kind of between C and B. You don't really know exactly where the sun is. It's estimate, so maybe something like that in this range. Definitely longer than this. Definitely longer, and somewhere between C and B. This stuff is tricky for the average kid in my class. It's just a hard thing to grasp. That's why we do a lot of it. Next up is this fact. September 21st, and it's really September 23rd. Somebody says 21st, but we'll use 23rd, sorry, is the first day of fall. It's called the fall equinox. The sun rises due east, and it sets due west on that day. In New York, the sun is 48 degrees above the horizon at solar noon. On the diagram above, draw on the sun's path for September 20, and again 23rd. Close enough. All right. Well, rises due east. That's here. Rise here is going to go up in the sky. It is going to set due west right here, sunset. Highest it gets, solar noon, 48 degrees. That's right. It's going to be right there. It's a little hard for me to... Right there, right? And then you got to draw the path. Rise here. Go up to there. Set there. Arrows go like this. If you want to put arrows on it, I don't tell you to, but good to get that idea. Okay, that's how that works. Know this, how this works, really work through it. Watch this video again if you need to. 10. The diagram above shows the location of a post at solar noon on March 21st. Draw an arrow pointing west. Label it west. Remember, the shadow at solar noon points due north. Okay, so this is solar noon. That's good. So therefore, this way, that way's north. That way's south. Okay, and therefore, this way will be east. And then it gets me to this direction here. That is west. Label it W. So you really had to just do this. I did this. I need to do that to help me figure this out. But that's your arrow approximately where west is, and this should be a W. 11. Drawing the length of the shadow at solar noon on January 1st. Length and direction matter. Okay, this you need to know. I guess it's not in here anywhere, but know that on January 1st, the sun is much lower in the sky. That's why it's winter. The sun is lower in the sky, lower path. So the shadow, again, at solar noon, will point the same direction, but because the sun is much lower in the sky than on this day, March 21st, the length of the shadow will be longer. So it's kind of an interesting thing to draw. You same direction, you just make it longer. Maybe you go like this. Okay, with the idea that you then kind of color over it, so the shadow would be here. Okay, and that hopefully you can understand that and see what I mean by that. But that is why it is winter. The sun is lower in the sky, gives you less direct energy when it's lower in the sky, and that's what causes winter. So that's key. The diagram below shows Earth's orbit around the sun. Locations A, B, C, D represent Earth on the first day of each season. Which location represents March 21st? Okay, this is a little tricky, and it's multiple choice. This, I'll say the axis is, it's a weird perspective here. Okay, and feel free to draw on these all you'd like. Okay, this North Pole is tilted away from the sun. So this is winter. And use the first page if you need to. This, the North Pole is tilted towards the sun. This is summer. Okay, and it goes this way. So March 21st is between winter and summer, halfway between. So it should be A. Your answer should be A, and it should be A. Too many people see summer, winter, and they put it here, but you really got to think winter into summer. March is between there. So winter into summer, it should be A. All right, be careful. This picture here, 13, I drew the arrows in of of how the sun moves through the sky. That's what these represent, the movement. Okay, and it has, and this also should be March 21st as well. On the diagram above, draw a dot at the location the sun sets on December 21st. Label it M. So right here, okay, that's the sunset. As I put the arrows on there, label it M, showing the sunset. Now, this is due west, that's due east, due south, due north. So, 14, the position of point M is best described as due west, no, not due west, south of due west. Here's due west. It is towards the south of it. That sounds right. Or north of due west. That is due west towards the north. That's up here. That's not true. So, best answer to south of due west is what we call that. South of due west. Okay, so hopefully that works for you. Watch this again. Okay, people who come see me ask questions is good. For Mr. Gazda and all the folks at Gazdonian Productions, thanks for watching.